In the quiet stillness of evening, when the day's movement has softened into a slow and steady rhythm, the body begins its gentle shift toward rest. Muscles loosen, breathing deepens, and the mind starts to settle into the calm that precedes sleep. This is a perfect moment to turn our attention inward, to explore the subtle but profound work of two systems that rarely make themselves known to our conscious mind: the endocrine system and the immune system. These two systems are unlike the ones we can easily feel. We can sense our heartbeat after climbing a hill, notice our lungs drawing in cool air, or hear the gurgle of our digestive tract after a meal. But the endocrine and immune systems operate quietly, without sound or obvious sensation. They are constant, tireless guardians and coordinators, ensuring that the body functions smoothly, whether we are awake and active or asleep and dreaming. The endocrine system is a master of communication. It sends messages in the form of hormones, chemical messengers that travel through the bloodstream, influencing organs and tissues far from their point of origin. These messages are not loud, not hurried, but instead deliberate and precise. A hormone released from a gland in the brain might travel to the adrenal glands above the kidneys, prompting them to adjust energy availability. Another hormone may help the body prepare for sleep, guiding metabolism into a slower, restorative pace. Each one has its role, its own destination, and its own timing. Together, these messages form a conversation that never ends. The immune system, on the other hand, is a guardian. It is constantly present, constantly aware of what is happening in the body's tissues, fluids, and surfaces. Its task is to protect, to ensure that everything inside belongs, and to remove anything that does not. It does this with remarkable efficiency and a kind of quiet wisdom. Most of the time, its work passes unnoticed. You do not feel your immune cells circulating through your lymph nodes or patrolling your bloodstream. You do not sense the subtle signals they exchange, or the microscopic repairs they carry out, but they are always there, watching, ready to act if needed. What makes these two systems especially remarkable is how they work together. The endocrine system can influence the immune system's readiness, raising or lowering certain responses depending on the body's needs. The immune system can, in turn, signal the endocrine system to adjust the body's priorities, perhaps conserving energy for healing or releasing resources to meet a challenge. Their connection is a conversation that has been refined over millions of years of evolution. It is not a hurried exchange, but a slow, steady dialogue, built on understanding and cooperation. One way to imagine their relationship is to picture the body as a great, ancient library. The shelves are filled with countless volumes, each containing the instructions for some part of life: how to breathe, how to digest, how to heal a wound. The endocrine system is like the head librarian, quietly moving through the aisles, delivering notes, making sure every section has the right information at the right time. The immune system is like the gentle night watch, patrolling the quiet halls, ensuring nothing is out of place, that every book is safe and undisturbed. The library is always active, but never noisy. Work is being done, but the peace is never broken. Even now, as you listen and perhaps begin to feel the weight of sleep drawing closer, these systems are active. The pineal gland, a small but important part of the endocrine system, is releasing melatonin into your bloodstream, helping your mind and body move deeper into rest. The immune system is using this period of stillness to carry out many of its important tasks, identifying and removing damaged cells, creating new defenders, and storing away memories of past encounters so that it will be ready for the future. Neither system demands your attention. They work in the background, leaving you free to drift deeper into calm. The endocrine system is made up of glands spread throughout the body: the hypothalamus and pituitary in the brain, the thyroid and parathyroid in the neck, the adrenal glands above the kidneys, the pancreas tucked behind the stomach, and the reproductive glands. Each of these glands produces hormones with specific jobs, from controlling metabolism and growth to influencing mood and reproduction. Their combined efforts keep the body in balance, adjusting to the subtle changes that happen every day. The immune system is spread even more widely. Its cells travel in the blood and lymph, inhabiting tissues and forming specialized structures like lymph nodes and the spleen. Its presence is everywhere, from the surface of the skin to the deepest internal organs. It does not simply react to threats, it learns from them, remembers them, and prepares for the future. In this way, it is both a guard and a teacher. These two systems often meet in their work. Stress, for example, can trigger the adrenal glands to release cortisol, a hormone that helps the body adapt, but can also influence how immune cells behave. Hormones involved in reproduction can alter immune responses, ensuring that the body protects developing life without overreacting. Even sleep itself is a time of cooperation. Hormones released during rest can support immune function, and immune activity can shape the way the endocrine system guides recovery. The beauty of their cooperation lies in its invisibility. You do not need to think about adjusting hormone levels or directing immune responses. These systems operate with a wisdom that does not require your conscious involvement. In fact, their success is often measured by how little you notice them. When hormones are balanced and the immune system is in harmony, you simply feel well. Energy is steady, sleep is restful, and the body recovers easily from life's small challenges. It is easy, in the rush of daily life, to forget about these silent guardians. We notice discomfort, illness, or imbalance, but rarely stop to appreciate the long stretches of health they quietly maintain. Yet, every moment of stability is their doing. Every breath taken without strain, every wound that heals without trouble, every night of peaceful rest is made possible by their constant, measured work. So, as we begin this journey through the endocrine and immune systems, we do so at their pace, unhurried, calm, and deliberate. We will move from one part to another, just as they pass their signals and messages, linking each idea with the next in a gentle, seamless flow. There will be no rush to the end, only a steady unfolding of the connections that make these systems essential to life. And perhaps, as we move deeper into this exploration, you may find yourself breathing a little slower, feeling the gentle pull of rest. This is fitting, for the work of these systems is most visible if only to those who know where to look in the stillness of night. The endocrine system continues its quiet orchestration, the immune system maintains its patient watch, and you, the one they protect, can simply rest. They do not ask for recognition. They do not need applause. Yet, their presence is a reminder that even in the quietest moments, great and intricate work is being done. And tonight, as we begin, we honor that work, not with noise, but with the same stillness in which it thrives. 2. The endocrine and immune connection. The body is not a collection of separate parts working in isolation. Instead, it is more like a woven tapestry, each thread dependent on the others, each color blending into a larger picture. The endocrine and immune systems are two distinct networks, yet they are closely interlaced. They speak to each other constantly, sometimes in whispers, sometimes in more insistent tones, shaping how the body responds to the world and how it maintains balance within. The endocrine system sends its messages in the form of hormones, chemical messengers that drift through the bloodstream to distant tissues. The immune system, for its part, communicates through signals called cytokines, small proteins that allow immune cells to coordinate with each other and with other systems. These two languages, though different, can be translated by the body. Hormones influence immune cells. Cytokines influence endocrine glands. The conversation flows both ways, often so quietly that we never know it is happening. When you encounter a change in your environment, a shift in temperature, a challenge to your health, or even a change in emotional state, the endocrine and immune systems adjust together. Stress, for instance, is one of the clearest examples of their collaboration. When the body senses a challenge, the hypothalamus in the brain signals the pituitary gland, which in turn directs the adrenal glands to release cortisol. This hormone mobilizes energy, helping you meet the moment. At the same time, cortisol gently modulates the immune system, making sure that resources are used where they are most needed. The relationship works in reverse as well. If the immune system detects a potential threat, perhaps a virus or bacteria, it begins releasing cytokines. These molecules do not just alert other immune cells. They can also reach the brain and influence the hypothalamus. This can lead to subtle adjustments in hormones, shifting the body's focus toward healing and recovery. You might feel a natural pull toward rest. Your appetite may change, and your energy may slow, all signs that the endocrine system has responded to immune messages. This connection extends into daily rhythms, even when there is no obvious challenge. Hormones such as melatonin, produced by the pineal gland, influence both sleep patterns and aspects of immune function. Growth hormone, released in pulses during deep sleep, supports tissue repair and immune activity. These patterns continue quietly in the background, part of the body's ongoing dialogue between regulation and protection. You can imagine the two systems as neighboring villages along the same river. The endocrine system's messages flow downstream as gentle currents, carrying instructions for growth, repair, and balance. The immune system's signals travel upstream, carrying news of conditions, resources, and safety. Neither can thrive without the other's information. If one sends a message, the other adjusts its own work to match. Even long-term health depends on this relationship. A well-balanced endocrine system supports a steady, resilient immune response. A healthy immune system ensures that the body's inner environment remains stable, allowing hormones to do their work effectively. Disruptions to one system can ripple outward, affecting the other, which is why their harmony is so vital. The beauty of this partnership lies in its subtlety. There are no sharp lines dividing where one system ends and the other begins in their effects. Instead, they overlap, sharing responsibilities and adjusting together in ways that feel almost seamless. This is the quiet, mutual care that allows the body to adapt to life's constant changes. And so, as we continue our journey through each system, we keep in mind that every detail, every hormone, every immune cell is part of this larger conversation. In the stillness of the night, as you rest, these two systems will still be speaking to each other, maintaining the balance that allows you to wake renewed. 3. The master conductor, hypothalamus and pituitary gland. In the quiet architecture of the brain, tucked deep beneath the folds of the cerebral hemispheres, lies a pair of small but powerful structures that together guide much of the body's internal harmony. The hypothalamus and the pituitary gland are not large in size. The hypothalamus is scarcely larger than a fingertip, and the pituitary no bigger than a small pea, yet their influence reaches every corner of the body. They are the central conductors of the endocrine orchestra, setting the tempo, cueing each section, and ensuring that every gland and tissue works in unison. The hypothalamus is the bridge between the nervous system and the endocrine system. It sits just above the pituitary gland, its shape resembling a tiny arch, its tissue woven with nerve cells that can sense changes in the body's internal environment. It receives constant updates: the temperature of the blood, the balance of water and salts, the levels of key hormones, and even signals from the immune system. It processes this information quietly, without stirring your awareness, and decides whether adjustments are needed. When the hypothalamus acts, it often does so by speaking to the pituitary gland, which hangs just below it in a small, protective cradle of bone. The two are connected by a delicate stalk of tissue containing both nerve fibers and tiny blood vessels, allowing messages to pass with both speed and precision. Some signals move electrically, along nerves, others travel chemically, as releasing hormones carried in a special network of capillaries from the hypothalamus to the pituitary. The pituitary, often called the master gland, responds to these cues by releasing its own hormones, many of which direct other endocrine glands. When the hypothalamus signals the pituitary to release thyroid-stimulating hormone, for example, the thyroid gland in the neck responds by adjusting metabolism. A signal to release adrenocorticotropic hormone prompts the adrenal glands to prepare the body for activity or adaptation. In this way, the pituitary acts as a central relay, turning the hypothalamus's quiet plans into actions that ripple outward. Not all of the pituitary's work involves other glands. Some of its hormones act directly on the body's tissues. Growth hormone, for instance, influences cell repair, protein synthesis, and the building of muscle and bone. Prolactin supports milk production after childbirth. Oxytocin, produced in the hypothalamus but stored and released by the pituitary, plays roles in childbirth, bonding, and gentle regulation of stress responses. Each release is timed and measured, shaped to fit the body's needs at that exact moment. In the stillness of night, when your breathing is slow and even, the hypothalamus and pituitary remain quietly alert. They help regulate your body temperature, keeping it within a comfortable range. They coordinate the release of hormones that encourage tissue repair and immune activity during sleep. They maintain balance in water and salt levels so that cells remain in perfect working order. The relationship between these two structures is one of deep trust and constant dialogue. The hypothalamus gathers information from across the body and the brain, forming a complete picture of the body's state. The pituitary takes this picture and translates it into precise hormonal instructions. Then, feedback from other glands returns to the hypothalamus, letting it know whether adjustments are working or further fine-tuning is needed. This loop sensing, signaling, responding, and adjusting continues without pause. It is worth noting that while they are often described in mechanical terms, their coordination is more like an art than a simple switchboard. The hypothalamus does not just respond to one signal at a time. It considers many inputs at once, blending them into a balanced response. The pituitary, in turn, releases hormones in carefully modulated pulses rather than constant streams, allowing the body to respond naturally without strain. When we think of orchestras, we often imagine the conductor standing above the musicians, guiding them through the rise and fall of sound. The hypothalamus and pituitary serve the same role in the body's internal symphony. They ensure that each part plays its role at the right moment, not too loud, not too soft, and always in time with the whole. As you rest, this master conductor's work is subtle, but essential. Your heartbeat remains steady, your body temperature holds in its comfortable range, and the quiet exchanges between cells and systems continue without disruption. These small structures, hidden from view and silent in their operation, are among the most important guardians of your well-being. Their steady leadership allows all other systems to work together, forming the foundation for the calm, restorative state you experience now. 4. The butterfly of the neck, thyroid, and parathyroid glands. Resting gently at the front of the neck, just below the curve of the Adam's apple, lies a small yet vital structure shaped like a butterfly. This is the thyroid gland, its two soft lobes connected by a narrow bridge of tissue. Though light in weight and delicate in form, the thyroid quietly influences nearly every cell in the body. Nestled just behind it are the parathyroid glands, four tiny, rounded structures that are no larger than a grain of rice. Together, these glands play a key role in keeping the body's metabolism and mineral balance steady, moving in harmony with the needs of the moment. The thyroid's work begins with a message from the pituitary gland. In response to signals from the hypothalamus, the pituitary releases thyroid-stimulating hormone, or TSH. This is the thyroid's gentle cue to produce its own hormones, mainly thyroxine, T4, and a smaller amount of triiodothyronine, T3. Once released into the bloodstream, These hormones travel to nearly every cell, guiding the speed of the body's metabolic processes. They influence how quickly energy is produced, how warm the body feels, and how actively the cells perform their daily work. In the stillness of the night, when the body is at rest, the thyroid does not sleep. Its influence continues quietly, ensuring that even in the slow rhythms of deep rest, the body's functions remain balanced. It helps maintain an even body temperature, supports the steady work of the heart, and keeps the brain's metabolism at a pace that allows for both repair and readiness. Just behind the thyroid's broad, delicate wings sit the parathyroid glands, small but essential partners. Their role is to regulate calcium levels in the blood and tissues. Calcium is not only a building block for bones and teeth, it is also crucial for nerve function, muscle contraction, and the release of certain hormones. The parathyroid glands monitor calcium levels with great precision, releasing parathyroid hormone PTH when levels drop too low. This hormone signals the bones to release small amounts of calcium, the kidneys to conserve it, and the digestive system to absorb more from food. The balance between the thyroid and parathyroid glands is an example of the body's elegant cooperation. While the thyroid shapes the pace of life through metabolism, the parathyroids keep the electrical and muscular systems finely tuned through mineral balance. Neither system overshadows the other. Both carry out their work with a quiet constancy, like two instruments playing in the same gentle key. Because these glands are small and their work is silent, it is easy to forget they are there. Yet their influence is felt in every movement, every thought, and every moment of rest. Without the thyroid's steady hormonal guidance, cells would not know whether to work quickly or slowly. Without the parathyroid's careful attention, muscles and nerves could not respond with the smooth precision that makes movement effortless and breathing steady. Their shape and position are also part of their poetry. The thyroid, with its butterfly form, seems almost to represent the lightness of balance it maintains, wide enough to touch both sides of the neck, but delicate in every detail. The parathyroids, hidden behind it, show that the smallest structures can carry some of the most important responsibilities. As you rest tonight, these glands are working for you. They are not demanding energy or sending urgent signals. Instead, they are maintaining the background hum of health, ensuring that the body's chemistry stays within the narrow ranges that allow every other system to function well. Like gentle keepers of a small vital flame, they ensure that warmth, energy, and balance are preserved until the morning light returns. 5. The adrenal glands, responding without alarm. High in the abdomen, just above the curve of each kidney, lie two small but remarkably influential structures, the adrenal glands. They are triangular in shape, soft in texture, and modest in size, yet their influence reaches into almost every aspect of the body's internal balance. Though often linked in the mind with sudden surges of energy or the fight or flight response, their true nature is far more nuanced. In the quiet cycles of everyday life, and especially in the still hours of rest, the adrenal glands work steadily, guiding adaptation, regulating resources, and preserving harmony without ever breaking the calm. Each adrenal gland is composed of two distinct regions, each with its own role and rhythm: the adrenal cortex, which forms the outer layer, and the adrenal medulla, which rests in the center. These two regions are different not only in structure but also in function, yet they are united in their shared mission to ensure the body's internal environment can meet changing needs without disruption. The adrenal cortex produces three primary groups of hormones, each essential to life. The first is cortisol, a glucocorticoid that influences the way the body uses energy. Cortisol's role is sometimes misunderstood, as it is often labeled simply as the stress hormone. In reality, it is not a substance to be feared, but one to be appreciated. Cortisol is always present in the bloodstream, rising and falling with the body's circadian rhythm. In the early morning, levels naturally rise, encouraging the release of stored energy so that muscles and the brain are ready for the day. By evening, cortisol levels fall, allowing the body to shift into a state more suited for rest and repair. Even during sleep, small, steady pulses of cortisol help maintain stability, ensuring that blood sugar levels remain adequate to support the quiet work of the heart, brain, and other vital organs. The second important hormone group from the adrenal cortex is the mineralocorticoids, with aldosterone being the most prominent. Aldosterone's task is subtle yet essential. It helps regulate the body's sodium and potassium levels, which in turn control the volume and pressure of fluids in the blood vessels. Without this constant, fine-tuned balance, even simple processes like maintaining steady circulation would be disrupted. Aldosterone works in partnership with the kidneys, signaling them when to conserve sodium and when to release it, ensuring that hydration levels remain consistent and that the electrical signals used by muscles and nerves flow without interruption. The third group of hormones from the adrenal cortex includes small amounts of androgen sex hormones that, though produced in greater amounts by the reproductive glands, also originate here. In both men and women, adrenal androgens contribute to the maintenance of muscle tone, bone strength, and even mood. Beneath the cortex lies the adrenal medulla, the inner core of the gland. The medulla produces adrenaline, epinephrine, and noradrenaline, norepinephrine, powerful messengers that can quickly adjust the body's readiness to meet a challenge. In moments of urgency, these hormones increase heart rate, focus attention, and prepare muscles for action. Yet in the absence of such moments, as in the calm of a quiet evening, their levels are low, circulating gently, maintaining just enough tone in the cardiovascular system to keep the body poised but not disturbed. The adrenal glands are in constant conversation with the brain, particularly with the hypothalamus and pituitary gland. This connection forms what is known as the hypothalamic pituitary adrenal HPA axis, a feedback loop that ensures hormone levels are precisely matched to the body's needs. When the hypothalamus senses a change, it sends a signal to the pituitary, which then prompts the adrenals to adjust their hormone output. This process is ongoing and smooth, like a careful adjustment of volume and tempo in an orchestra. The adrenal glands also speak to the immune system. Cortisol, when present in just the right amounts, can help keep immune responses balanced, preventing them from becoming unnecessarily aggressive. This is part of the body's wisdom, a reminder that readiness is not the same as overreaction. Likewise, immune signals can influence adrenal function, prompting shifts in hormone release during times when healing must take priority over other activities. Even in sleep, their work does not pause. While you lie still, breathing slowly and evenly, the adrenal glands continue their quiet regulation. Cortisol levels dip to their nightly low but remain sufficient to sustain the brain's nighttime activity. Aldosterone maintains the careful distribution of fluids, preventing imbalances that might disturb rest. In the early morning hours, the adrenals begin their gentle preparation for waking, gradually increasing cortisol so that, when you open your eyes, your body will already be ready to greet the day without shock or strain. One of the most remarkable qualities of the adrenal glands is their adaptability. They do not release the same amounts of hormones every day, but rather respond to subtle shifts in environment, activity, and health. They adjust to seasonal changes, to variations in diet, and to the gradual patterns of aging. This adaptability is part of what allows humans to live in so many different environments, from warm, humid lowlands to cold, thin mountain air. The adrenal glands are, in essence, the body's internal adjusters, fine-tuning the chemistry of life to suit the moment. The placement of the adrenal glands atop the kidneys is both practical and poetic. From this elevated position in the abdomen, they can receive a rich blood supply, allowing them to monitor changes in circulation and chemistry with ease. Their shape, narrow at the base, wider at the top, mirrors their role, rooted in specific functions. yet broad in their influence. During times of deep rest, like now, their most important contribution is preservation. They maintain stability so that your body remains in its most restorative state. They ensure that blood pressure remains steady, that energy reserves are managed wisely, and that no sudden shifts disturb the calm of sleep. If an unexpected need arises, a noise in the night, a sudden movement, they are prepared to respond. But until then, they hold the body in a state of gentle readiness, never breaking the peace. When considered this way, the adrenal glands are not simply stress glands, as they are sometimes labeled. They are guardians of equilibrium, keeping the body's chemistry in balance during both stillness and movement. They respond to life's challenges, yes, but they also sustain the calm in between, a role just as vital, and perhaps more often overlooked. As you rest now, they are working for you not with alarm, but with care. Every heartbeat, every steady breath, is supported in part by their quiet vigilance. They are among the many silent allies within, keeping you balanced, ready for tomorrow, yet undisturbed in the peaceful rhythm of tonight. 6. The pancreas. Steady keeper of blood sugar, tucked deep in the upper abdomen, behind the gentle curve of the stomach, and nestled between the loops of the small intestine, lies a quiet but essential organ, the pancreas. It is soft in texture, pale in color, and shaped a little like a leaf, broad at one end and narrowing toward the other. Though it works in silence and is often overlooked, the pancreas plays a vital role in maintaining the body's energy balance. It does so with a calm precision, adjusting the supply of fuel to match the body's needs at every moment of the day and night. The pancreas is unusual in that it serves two distinct functions, one as part of the digestive system and one as part of the endocrine system. In its digestive role, it produces enzymes that help break down food so that nutrients can be absorbed. In its endocrine role, it releases hormones directly into the bloodstream, influencing how the body uses and stores energy. These two roles are carried out in perfect harmony, allowing the pancreas to support the body's needs from the moment food is consumed to the time nutrients are used by the smallest cells. The pancreas's endocrine work is done by small clusters of specialized cells known as the islets of Langerhans. These tiny islands of tissue are scattered throughout the organ, and within each islet are several different types of cells, each producing a different hormone. The most well-known of these is insulin, produced by beta cells. Insulin's task is to help move glucose, the body's primary form of sugar, from the blood into the cells, where it can be used for energy or stored for later. Working alongside insulin is glucagon, a hormone produced by alpha cells. While insulin lowers blood glucose levels by encouraging its uptake and storage, glucagon raises blood glucose by prompting the liver to release stored sugar back into the bloodstream. The balance between these two hormones ensures that the body's cells have a steady supply of energy, whether you have just eaten a meal or have been sleeping for several hours. This balance is maintained with remarkable sensitivity. Even the smallest rise or fall in blood sugar is detected by the pancreas, which responds with a corresponding adjustment in hormone release. After a meal, as sugar from digested food enters the blood, insulin secretion increases. During the night, when you are fasting, insulin levels fall and glucagon gently rises, preventing the blood sugar from dropping too low. In this way, the pancreas acts much like a caretaker of a quiet hearth, adding just enough fuel to keep the fire burning steadily, never too much to cause a flare, and never so little that the flames grow weak. This constancy is vital, for the body's cells, especially those of the brain, depend on a continuous supply of glucose to function. The pancreas also works in quiet cooperation with other glands and systems. Hormones from the adrenal glands, such as cortisol, can influence blood sugar levels, prompting the pancreas to adjust its output. Signals from the digestive tract, released when food enters the stomach and intestines, can prepare the pancreas to begin releasing insulin even before the nutrients reach the blood. The liver, too, works in partnership, storing glucose after meals and releasing it when the pancreas signals that it is needed. At night, while you rest, this partnership continues in the background. The pancreas monitors blood sugar, making subtle adjustments that keep levels steady through the long hours between meals. The changes are so smooth that you never notice them. Your heart continues to beat with even strength, your breathing stays regular, and your brain remains nourished, whether you are in light sleep or in the deepest slow-wave phases. The pancreas's role in the digestive process also contributes indirectly to this stability by producing enzymes that break down carbohydrates, proteins, and fats. It ensures that nutrients are available in a form the body can use efficiently. This process supports the steady release of energy after eating, preventing sudden swings in blood sugar. The position of the pancreas in the body is well suited to its dual role. Resting close to the stomach and small intestine, it can quickly release its digestive secretions into the digestive tract. At the same time, its rich blood supply allows hormones from its islets to enter the circulation within moments, reaching distant tissues swiftly and efficiently. Though the pancreas works continuously, it is never in a rush. Its adjustments are precise and proportionate, reflecting the body's actual needs. This is one of its greatest strengths, the ability to act decisively when necessary, but always with restraint. Like a quiet steward managing a household, it ensures that resources are distributed wisely, waste is minimized, and stability is preserved. The balance of insulin and glucagon is part of a larger pattern in the endocrine system, the pairing of opposing forces that keep the body's internal environment within narrow limits. Just as the sympathetic and parasympathetic branches of the nervous system balance each other, insulin and glucagon create a dynamic equilibrium that supports both rest and activity. In the calm of the night, the pancreas's contribution may seem invisible, yet it is essential. Every cell in the body depends on the steady flow of glucose that the pancreas helps maintain. Without this stability, the delicate processes of repair and restoration that occur during sleep would be disrupted. The immune system, which carries out much of its work in these hours, also relies on this steady energy supply to perform its tasks effectively. The pancreas's quiet dedication is a reminder that balance is not achieved through extremes, but through small, continuous adjustments. It is not a gland that calls attention to itself. Instead, it embodies the principle of steady support, always present, always responsive, and always in service to the body's overall harmony. As you rest now, the pancreas is working for you. It measures the ebb and flow of blood sugar with the precision of a gentle tide, making sure that your cells are nourished, your mind remains at ease, and your body is prepared for the new day ahead. It does not need recognition, for its reward is the stability it preserves. And in that stability lies the foundation for deep rest and lasting health. 7. The pineal gland, keeper of the sleep-wake cycle. Deep within the center of the brain, sheltered between the two hemispheres, and cradled in a small groove, where the rounded thalamic structures meet, rests a tiny gland no larger than a grain of rice. This is the pineal gland, a delicate, pine-cone-shaped organ whose influence reaches far beyond its size. For centuries, it has been the subject of curiosity, both for its unique location and for its intimate connection with the rhythms of day and night. In the modern understanding of biology, the pineal gland stands as the body's quiet timekeeper, guiding the transitions between wakefulness and rest with a gentle precision. The pineal gland's primary work is the production and release of melatonin, a hormone that plays a central role in regulating circadian rhythms, the natural, repeating cycles of sleep and wake that govern much of life's internal timing. This process begins not within the pineal itself, but with light. Specialized cells in the retina of the eyes detect brightness and darkness, sending this information along a dedicated pathway to the brain's master clock, the suprachiasmatic nucleus, a small cluster of neurons in the hypothalamus. From there, Signals travel through a winding network of nerve connections until they reach the pineal gland. When daylight is abundant, the pineal remains mostly quiet, producing little melatonin. This helps keep the body alert and in tune with the active hours of the day. As evening approaches and light levels fade, the signals reaching the pineal change. In response, it begins to produce melatonin in greater amounts, releasing it into the bloodstream, where it can reach cells throughout the body. This rise in melatonin acts like a gentle invitation, encouraging the mind to slow, the body to relax, and the intricate systems within to shift into their nighttime mode. Melatonin's effects are subtle yet profound. It does not act like a sedative, forcing sleep upon the body. Instead, it guides the internal environment toward the conditions that make sleep possible. It lowers body temperature slightly, helping to prepare the body for rest. It influences blood pressure and the timing of other hormones, such as cortisol, whose own rhythms are in a delicate dance with melatonin's. It also has antioxidant properties, offering protection to cells during the night when the body is engaged in repair and renewal. The pineal gland's rhythm is consistent but adaptable. It responds not only to the daily cycle of light and darkness, but also to changes in season, adjusting melatonin production to match the length of nights. In this way, it helps the body stay in harmony with the environment, an echo of ancient patterns when human activity was more directly shaped by the shifting balance of daylight and darkness. While the pineal gland is best known for its role in sleep, its influence extends to the immune system. Melatonin can interact with immune cells, supporting the coordination of their nighttime activities. This is part of the reason why rest is so closely linked with healing. The pineal gland's guidance over the body's daily timing allows the immune system to perform its maintenance and repair work with optimal efficiency. During the quiet hours of the night, when the world outside is still, the pineal gland is at its most active. Its melatonin flows steadily into the bloodstream, sending a clear but gentle message to every part of the body. This is the time for rest, recovery, and renewal. The heart beats in a slower, more economical rhythm. The breathing deepens. Muscles release their tension. The mind drifts more easily into the layered cycles of sleep, where memory is organized, tissues are repaired, and energy is restored. It is important to understand that the pineal gland's work is never forceful. Its power lies in its constancy and in the quiet authority of timing. The changes it orchestrates occur without suddenness. One phase flows naturally into the next. In the morning, as light enters the eyes once more, melatonin levels begin to fall. The pineal retreats into its daytime stillness, allowing wakefulness to rise naturally in its place. The pineal's small size belies the elegance of its structure. Under a microscope, its tissue is composed of pinealocytes, specialized cells that produce melatonin interspersed with glial cells that offer support and structure. The gland is rich in blood supply, ensuring that melatonin can quickly enter circulation and reach the farthest parts of the body. In older age, the pineal often develops tiny mineral deposits known as brain sand, a feature noted for centuries, though their presence does not diminish its essential role. Its location in the brain's center seems fitting for a structure that serves as a unifying timekeeper. From this position, it can coordinate with other systems, the nervous system, the endocrine system, and the immune system, ensuring that the cycles of rest and activity are synchronized across the whole body. It is not a solitary actor, but a leader in a larger orchestra of rhythms. As you rest tonight, your pineal gland is at work. The darkness that surrounds you is its signal to release the gentle tide of melatonin, helping each cell understand that the time for activity is passing and the time for restoration has begun. You may not feel this transition consciously, but it is happening all the same, moment by moment, in the background of your awareness. In many ways, the pineal gland represents the essence of what the body's quiet systems do best, working without noise or intrusion. shaping the conditions that allow health and balance to flourish. Its message is not one of urgency, but of gentle guidance, reminding the body to follow the rhythm that has been part of life for countless generations. And so, as you lie here in stillness, the pineal gland continues its quiet watch, aligning your inner world with the natural flow of time. Each pulse of melatonin carries with it an ancient truth that rest is not simply the absence of activity, but a purposeful, restorative state, as essential to life as the brightest hours of the day. 8. Reproductive hormones, cycles, and continuity. In the intricate web of the endocrine system, few areas reflect the rhythm of life as vividly as the reproductive hormones. These messengers, produced in both male and female bodies, are not solely concerned with reproduction itself. They shape growth, influence mood, maintain bone strength, support metabolism, and contribute to the body's overall harmony. Their presence is constant, though their levels rise and fall in patterns that echo the deeper cycles of nature daily, monthly, and across the years. In females, the primary reproductive hormones are estrogen, progesterone, and a small but important contribution of androgens. These are produced mainly in the ovaries, though the adrenal glands also add to their supply. Estrogen is often called the hormone of growth and renewal. It supports the development of reproductive tissues, maintains the health of the uterus, and influences the condition of skin, hair, and bones. It also has subtler roles, such as shaping patterns of fat distribution, influencing brain chemistry, and even affecting the health of the cardiovascular system. Progesterone, by contrast, is often thought of as the hormone of preparation and stability. It plays a key role in the second half of the menstrual cycle, preparing the lining of the uterus for a potential pregnancy and helping to maintain the early stages of gestation if conception occurs. Beyond reproduction, progesterone also has a calming effect on the nervous system, promoting a sense of steadiness and supporting restorative sleep. These two hormones are not in constant competition, but in a partnership that changes with the cycle. In the early days, estrogen gently rises, encouraging renewal and growth. Midway through, its peak triggers the release of an egg ovulation. Following this, progesterone takes the lead, ensuring that the body is ready for the possibility of nurturing new life. If pregnancy does not occur, both hormones gradually decline, and the cycle begins anew. In males, the principal reproductive hormone is testosterone, produced mainly in the testes, with small amounts from the adrenal glands. Testosterone supports the development of reproductive tissues, but it also influences muscle mass, bone density, red blood cell production, and mood. Its levels are highest in early adulthood and slowly decrease with age, though it remains important throughout life. Like estrogen in females, testosterone has effects far beyond reproduction, shaping the body's strength, vitality, and resilience. The regulation of reproductive hormones begins in the brain, in the hypothalamus and pituitary gland. The hypothalamus releases gonadotropin-releasing hormone, NRH, which prompts the pituitary to release luteinizing hormone, LH, and follicle-stimulating hormone, FSH. These, in turn, signal the reproductive organs, ovaries in females, testes in males, to produce their respective hormones. This process operates in a feedback loop where rising levels of estrogen, progesterone, or testosterone can signal the brain to adjust its instructions, ensuring that hormone levels remain within a range that supports health and balance. The patterns of these hormones are not limited to reproductive years. In early life, they guide the development of the body from infancy to adulthood, initiating puberty and the changes that come with it. Later, their gradual shifts mark transitions such as menopause in females, when estrogen and progesterone levels decline, and andropause in males, when testosterone gently decreases over time. These changes are not abrupt disruptions, but part of the body's broader rhythm, a reminder that the endocrine system adapts across the entire lifespan. Reproductive hormones also speak to other systems. Estrogen influences bone cells, helping to maintain density and strength. Testosterone interacts with muscle tissue, supporting repair and growth. Progesterone and estrogen can both influence brain activity, subtly affecting mood, memory, and even the perception of stress. The immune system, too, adjusts its activity in response to hormonal signals, ensuring that it works in harmony with reproductive needs. During sleep, reproductive hormones continue their quiet work. The body may not be actively reproducing, but these messengers still maintain tissues, regulate metabolism, and interact with other hormones like growth hormone and cortisol. In the deep, slow-wave phases of sleep, cells respond more readily to hormonal cues, making the night a time of renewal not only for the mind but also for the body's reproductive and supportive functions. These hormones also move in concert with broader environmental rhythms. Seasonal changes, for example, can influence reproductive hormone patterns in subtle ways, a reflection of ancient biological ties to cycles of light, temperature, and resource availability. While modern life may shield us from some of these influences, the underlying responsiveness remains a quiet echo of the natural world. The reproductive system's hormonal patterns are a kind of living calendar, marking time in ways both visible and hidden. In females, monthly cycles weave together renewal, preparation, and release. In males, the pattern is less cyclical but still guided by daily and seasonal fluctuations. Over the course of life, these rhythms shift, yet their contribution to the body's balance remains steady. One of the most striking qualities of reproductive hormones is how they integrate with the whole. They are not isolated in their effects, nor do they act only in times of fertility. They influence the structure and function of systems throughout the body, often in ways we may not notice until we pause to reflect. Strong bones, healthy muscles, clear thinking, and stable mood are all touched by their presence. As you rest now, your reproductive hormones are moving in their own patterns, some rising, some falling in tune with the deeper cycles that have been part of human biology for countless generations. Their work is not hurried. They follow the pace of nature itself, shifting gently, ensuring that the body remains in balance. In this way, they embody the principle that life's continuity depends not only on moments of change, but also on the steady, unbroken flow of time. 9. The immune system, gentle guardian of health. Beneath the surface of the skin, within the quiet flow of the blood, and in the delicate tissues that line the body's inner passages, there exists a network of guardians that work tirelessly to protect, repair, and maintain balance. This is the immune system, a living, adaptable shield that stands between the body and the countless microorganisms and environmental challenges it encounters each day. It is not a wall of rigid defense, but a responsive, intelligent presence, able to distinguish between friend and foe, and to adapt its strength to meet each situation with care. The immune system is not housed in a single organ. Rather, it is spread throughout the body, woven into the tissues of the skin, the bone marrow, the lymph nodes, and the spleen. It flows in the lymphatic vessels that run alongside the bloodstream, and it resides in the mucous membranes of the nose, mouth, lungs, and intestines. It is a system without a single center, yet every part knows its role and remains in constant communication with the rest. At the heart of this system are its cells, each with a unique purpose. White blood cells, or leukocytes, patrol the body in a quiet rhythm, moving through tissues and vessels like gentle sentinels. Some are phagocytes, designed to engulf and digest harmful particles. Others, like lymphocytes, coordinate more complex responses. T cells help regulate the activity of other immune cells, while B cells produce antibodies, proteins that recognize and neutralize specific invaders. These antibodies circulate silently, ready to respond the moment they encounter the target they were designed to match. The immune system operates on two levels, the innate and the adaptive. The innate immune system is the body's immediate, non-specific response to challenges. It is always on duty, ready to react within minutes. It includes physical barriers like the skin, chemical defenses like enzymes in saliva, and rapid cellular responses. The adaptive immune system, in contrast, is more deliberate. It takes time to respond, but its strength lies in its precision and its memory. Once it has encountered a particular invader, it remembers it, allowing for a faster, more effective response in the future. Even in the absence of illness, the immune system is active. It continually monitors the body's internal environment, removing damaged cells, repairing tissues, and keeping the population of microorganisms in balance. In the intestines, for example, immune cells work closely with beneficial bacteria, supporting a community that aids digestion and helps prevent harmful species from gaining a foothold. Communication is central to the immune system's work. Its cells send and receive signals in the form of small proteins called cytokines. These messages can encourage growth, direct movement, or trigger a coordinated response. Cytokines also link the immune system to the endocrine and nervous systems, ensuring that the body's defenses are in tune with its overall needs. If the immune system must act, it can signal the hypothalamus to adjust body temperature, creating a less favorable environment for certain pathogens. It can also influence sleep patterns, encouraging rest to conserve energy for healing. The immune system's adaptability is one of its most remarkable qualities. It learns from every encounter, refining its responses over time. This learning begins at birth, as the immune system encounters new antigens, the molecular signatures of the outside world, and begins to build its library of recognition. Throughout life, this process continues, shaping a defense system that is uniquely suited to the individual's environment and experiences. During sleep, the immune system's activity shifts into a mode that favors repair and reinforcement. Certain immune cells increase in number, and the production of cytokines that support healing and recovery is enhanced. Antibody production may rise, helping to strengthen defenses against challenges encountered during the day. This is why rest is so closely linked to resilience. The immune system uses these hours of stillness to prepare for the next day's encounters. It is worth noting that the immune system does not always respond with intensity. Much of its work is subtle, involving quiet adjustments that maintain equilibrium. It might allow harmless microorganisms to remain in place, recognizing their beneficial role, or it might gently remove damaged cells before they can cause trouble. Its goal is not to eliminate everything unfamiliar, but to maintain a healthy balance in which the body can thrive. The lymphatic system plays a key supporting role in this work. Lymph nodes act as small way stations, filtering the lymph fluid and giving immune cells a place to gather, share information, and coordinate their actions. The spleen serves as a larger hub, filtering the blood itself, removing worn-out red blood cells, and storing reserves of white blood cells and platelets. These structures are not busy markets of constant activity. Rather, they are like quiet meeting halls, where plans are made and carried out with steady purpose. The immune system's partnership with other systems is a theme repeated throughout the body. It works with the skin to prevent harmful entry, with the digestive system to manage the balance of bacteria, and with the circulatory system to transport its cells and messages. It also responds to hormonal cues from the endocrine system, which can modulate its intensity based on the body's needs at any given moment. As you rest now, your immune system is still at work. It moves with the slow, even flow of your breathing, the gentle pulse of your heartbeat. It checks each corner of the body, clearing away debris, repairing tissues, and quietly preparing for the day ahead. You may not feel its presence, but it is one of your most faithful companions, always alert, always adapting, always working for your well-being. In its quiet way, the immune system embodies the same principle seen in the rest of the body's harmonious systems. That balance is not achieved through constant force, but through steady, responsive care. Its work is a reminder that protection can be gentle, and that strength often lies in adaptability rather than resistance. And so, while you sleep, it continues its quiet watch, ensuring that you wake renewed, ready to meet the day with the resilience it has helped preserve. 10. Barriers and boundaries. The skin and mucous membranes. Surrounding the body like a seamless, living garment is the skin, the largest organ you possess, a quiet guardian that both separates and connects you to the world beyond. Together with the mucous membranes that line your inner passages, it forms a barrier both physical and responsive, a boundary that is as much alive as any organ within. These surfaces do far more than simply enclose the body. They sense, adapt, and protect with a quiet intelligence that works in harmony with every other system. The skin is composed of three primary layers: the outer epidermis, the supportive dermis beneath it, and the deeper subcutaneous layer that blends into the body's connective tissue and fat. The epidermis itself is a marvel of renewal, constantly shedding and replacing cells in a slow, silent cycle. Its outermost portion, the stratum corneum, is made of flattened, keratin-rich cells that form a tough, water-resistant shield. This barrier prevents excessive loss of moisture from within, while keeping harmful substances and microorganisms from entering. Though it may seem passive, this layer is constantly monitored and repaired, its strength maintained by a steady stream of new cells rising from the layers below. Beneath the epidermis, the dermis provides both strength and flexibility. It is composed of a supportive network of collagen and elastin fibers, bathed in a matrix that holds water and nutrients. The dermis is rich with blood vessels that help regulate temperature, sweat glands that release moisture to cool the body, and sebaceous glands that produce oils to keep the skin supple. It also houses an intricate web of nerve endings that provide the sense of touch, the ability to feel pressure, temperature, and texture, and to alert the body to potential harm in a way that is protective without being intrusive. Below the dermis lies the subcutaneous layer, a cushion of fat and connective tissue that insulates the body and stores energy. This layer also helps anchor the skin to the underlying muscles and bones, allowing movement without tearing the protective surface above. While the skin covers the exterior, the mucous membranes line the inner gateways of the body, the respiratory passages, digestive tract, urinary tract, and reproductive pathways. These membranes are soft and moist, adapted to their environments, and each serves as both a barrier and a point of exchange. The mucus they produce helps trap dust, microbes, and other particles, preventing them from moving deeper into the body. In the respiratory tract, cilia, tiny, hair-like structures, move in coordinated waves to sweep trapped particles upward, where they can be coughed out or swallowed. The digestive tract's mucous membranes work in a different way. They allow nutrients to pass from the food we eat into the bloodstream, while at the same time preventing harmful organisms from crossing. Specialized immune cells stationed just beneath these surfaces patrol constantly, ready to respond to anything that seems out of place. The skin and mucous membranes are not static defenses. They are living, responsive systems. When the skin is injured, cells near the wound quickly begin dividing to close the gap. Blood vessels widen to bring more nutrients and immune cells to the area, and the process of repair begins without delay. The mucous membranes can increase mucus production when they detect irritants, helping to flush out unwanted particles before they can cause harm. Temperature regulation is one of the skin's quiet yet vital contributions to health. When the body warms, blood vessels in the skin widen, allowing more heat to escape, and sweat glands release moisture that cools as it evaporates. When the body cools, these vessels narrow, and the insulating subcutaneous fat helps conserve warmth. This process is seamless. occurring without conscious thought, adjusting constantly to the environment. The skin also interacts closely with sunlight. In its outer layers, ultraviolet light triggers the production of vitamin D, an essential nutrient that supports bone health, immune function, and more. This transformation is a reminder that the skin is not simply a shield, but also an active participant in the body's overall well-being. Mucous membranes, too, are shaped by their environments. In the nose, mucus keeps the airways moist and filters out pollutants. In the stomach, the mucus layer protects the lining from the strong acids used in digestion. In the intestines, the mucus not only aids in the movement of food, but also creates a habitat for beneficial bacteria that support digestion and immune health. These protective boundaries are in constant communication with the immune system. Skin cells can release chemical signals to alert immune cells when a threat is present, and immune cells can, in turn, influence the activity of the skin and mucous membranes. This coordination ensures that the barrier is never simply a wall, but a living, sensing layer that participates in the body's defenses. At night, while you rest, the work of the skin and mucous membranes continues without pause. The skin undergoes repair, replacing cells damaged by the day's exposure to sunlight, wind, or friction. Blood flow to the skin increases during the early stages of sleep, bringing nutrients and oxygen needed for renewal. In the airways, mucus production and ciliary movement maintain their gentle clearing motion, ensuring that the passages are fresh and ready for the next day. In the digestive tract, the mucous membranes quietly prepare for the next meal, repairing and maintaining their lining. The beauty of these barriers lies in their quiet adaptability. They are as responsive to the stillness of the night as they are to the demands of the day. In calm conditions, they maintain their protective presence with minimal effort. When challenged, they respond proportionally, working to restore balance without unnecessary disturbance. In this way, the skin and mucous membranes are more than just the body's outer limits. They are the first chapter in the story of health, a living interface between self and world, shaped by and shaping the environment in which you live. Their work is constant, unheralded, and essential, a daily act of care that preserves the integrity of everything within. And as you sleep now, these quiet boundaries remain awake, their watch unbroken, holding the space between you and the outside world with a strength so gentle you hardly know it is there. In the morning, they will have done their work, and you will rise renewed, your body's delicate balance preserved by these steadfast keepers of your health. 11. The lymphatic network, pathways of protection. Threaded quietly throughout the body, often running parallel to the blood vessels, but with its own unique destinations, is the lymphatic network, a system of delicate channels, filtering stations, and protective hubs. It is not as well known as the circulatory system, yet it plays an equally vital role in preserving health. The lymphatic network is a bridge between the immune system and the circulatory system, moving fluid, carrying immune cells, and maintaining the body's internal environment with remarkable gentleness. At the heart of this network is lymph, a clear, almost colorless fluid that begins its journey as plasma within the blood. As blood circulates through the tissues, some of its fluid components seep out through tiny gaps in the capillary walls, delivering oxygen and nutrients to cells before bathing them in a supportive medium. Most of this fluid returns directly to the bloodstream, but a portion enters the lymphatic capillaries, becoming lymph. This subtle shift marks the start of a long and careful journey. Lymphatic capillaries are delicate structures with walls that open slightly to allow fluid, proteins, and even wandering immune cells to pass through. They are found in nearly every tissue of the body, quietly collecting the excess fluid that would otherwise accumulate and cause swelling. Once inside the lymphatic vessels, the fluid moves slowly, propelled not by a central pump like the heart, but by the rhythmic contraction of surrounding muscles and the gentle pressure of body movement. Along these pathways lie the lymph nodes, small, bean-shaped structures that serve as checkpoints and meeting grounds for the immune system. Within each node, lymph passes through a network of channels lined with immune cells. Here, harmful particles such as bacteria, viruses, or abnormal cells can be trapped and examined. If a threat is found, the immune cells within the node can mount a response, multiplying and releasing targeted defenses into the lymph before it re-enters circulation. The lymphatic system also includes larger structures like the spleen, which filters the blood itself, and the thymus, where certain immune cells mature before joining the body's defenses. In the intestines, specialized lymphatic vessels called lacteals absorb dietary fats and transport them into the bloodstream, ensuring that these essential nutrients are available to the body. An often overlooked function of the lymphatic network is its role in maintaining fluid balance. Without its constant collection and return of lymph to the bloodstream, even a small imbalance could lead to fluid buildup in the tissues. This quiet housekeeping ensures that the spaces between cells remain clear, allowing nutrients to reach them and waste products to be removed efficiently. The movement of lymph is unhurried, and its pace is perfectly suited to its purpose. Unlike the rapid flow of blood, lymph travels slowly enough for immune cells to inspect its contents thoroughly. This gentle rhythm is supported by the body's natural motions, walking, breathing, even the subtle movements that occur during sleep. In stillness, tiny valves within the lymphatic vessels prevent backflow, holding the fluid in place until movement resumes. During the night, the lymphatic system remains active. As the body rests, tissues continue their quiet exchange of nutrients and wastes, and the lymphatic vessels carry away the excess fluid and debris. In recent years, research has revealed that a similar system exists in the brain, sometimes called the glymphatic system, which becomes more active during sleep. This system helps clear metabolic byproducts from the brain's delicate environment, suggesting that the night is not only a time for rest, but also for deep cleansing at the cellular level. The lymphatic system's relationship with the immune system is one of partnership and constant communication. Lymph nodes act as places where immune cells can share information about what they have encountered, coordinate their responses, and even remember past encounters for quicker recognition in the future. This quiet coordination ensures that the body's defenses are prepared without creating unnecessary disruption to other systems. Its link with the circulatory system is equally essential. Lymph eventually returns to the bloodstream through large ducts near the base of the neck, completing its cycle. This return is not just about fluid. It also delivers immune cells to areas where they may be needed and maintains the overall volume and composition of the blood. The lymphatic network is often described as a secondary circulatory system, but in truth, it is more than that. It is a caretaker of balance, a messenger of the immune system, and a quiet collector of the body's stories. Every particle of lymph carries information about the state of the tissues it has visited. This information, in turn, shapes the immune system's understanding of the body's needs. The work of the lymphatic system is rarely felt directly. There is no pulse to mark its rhythm, no sound to announce its passing, yet its absence would be noticed almost immediately, for without it, the body's internal environment could not remain clear, nor could its defenses be properly coordinated. As you lie in stillness, this network is at work. It flows through your limbs, your torso, your head, carrying with it the quiet assurance of protection and balance. Every drop of lymph is moving toward the place where it will be filtered, examined, and eventually returned to the bloodstream. Every node it passes through is a place of watchfulness and care. And so, while it may remain invisible, the lymphatic network is a constant presence, a pathway of protection that touches every part of you. Its rhythm is slow, its work deliberate, and its purpose clear to keep the body's boundaries secure, its inner spaces clear, and its defenses ready, all without disturbing the calm that allows for deep and restorative rest. 12. Inflammation. the body's measured response. Within the immune system's vast repertoire of defenses, there exists a process as ancient as life itself: inflammation. Often misunderstood as something purely harmful, inflammation is, at its core, a carefully orchestrated response designed to protect and restore the body when it is injured or threatened. It is not chaos, though it may sometimes feel intense. It is a measured, purposeful sequence of events, each step leading toward healing. When functioning as intended, inflammation is not an enemy, but a deeply wise ally, stepping in only when needed and retreating when its work is complete. The roots of inflammation begin with detection. Throughout the body, immune cells stand watch, embedded in tissues or moving quietly through the bloodstream. When these cells sense damage, perhaps from a small cut, a burn, or the presence of bacteria, they send out chemical signals. These signals, often in the form of molecules called cytokines, are like quiet alarms, drawing other immune cells to the scene. The first visible sign of inflammation is often redness, caused by an increase in blood flow to the affected area. Blood vessels in the vicinity widen, a process called vasodilation, allowing more immune cells, nutrients, and oxygen to reach the site. Along with this, the vessel walls become slightly more permeable, so that immune cells can slip through into the surrounding tissue. This permeability also allows plasma, rich in proteins and other healing factors, to enter the area, creating the gentle swelling that is another hallmark of inflammation. Swelling, though sometimes uncomfortable, serves several purposes. It helps dilute any harmful substances that may have entered, provides a medium for immune cells to move within, and creates a localized environment rich in the materials needed for repair. At the same time, certain immune cells begin clearing away debris-damaged cells, foreign particles, or microorganisms, ensuring that the area is clean before rebuilding begins. Warmth is another natural feature of inflammation. It comes from the increased blood flow, but it also signals heightened activity in the area. Enzymes work more efficiently in slightly warmer conditions, and the immune system takes advantage of this subtle shift to speed its work. Pain, while often seen as purely negative, also has its place in the inflammatory process. It is produced both by the swelling, which presses on nearby nerves, and by specific chemicals released during the immune response. Pain serves as a quiet reminder to protect the area, to move it less, and to give it the stillness needed for repair. Once the immediate threat has been contained, whether it is a harmful microbe or the repair of damaged tissue, the same system that initiated inflammation also signals for it to subside. Anti-inflammatory molecules are released, swelling recedes, and the blood vessels return to their normal state. The cells that came to assist either depart or transform into cells that rebuild and strengthen the tissue. This resolution phase is as important as the initiation, for it ensures that the immune response ends cleanly, leaving the tissue restored rather than locked in a state of ongoing activity. In acute situations, such as a small wound or a mild infection, inflammation rises, does its work, and fades away in a matter of hours or days. It is a brief but vital period of heightened activity, much like the temporary scaffolding placed around a building during repairs. Inflammation is not limited to injuries from the outside world. It also responds to challenges within a joint, strained from overuse, a muscle microtear from exercise, or cells damaged by natural wear and tear. In each case, the process is the same: detection, recruitment of helpers, containment of the problem, and restoration of balance. This process is deeply intertwined with the rest of the body. The nervous system can influence inflammation, both enhancing and calming it as needed. Hormones from the endocrine system, such as cortisol, help regulate its intensity, ensuring that the response does not overshoot its purpose. The circulatory system carries immune cells to the area, while the lymphatic system helps remove debris and excess fluid afterward. During sleep, the body's ability to manage inflammation improves. The immune system can devote more resources to healing, free from the demands of active movement and digestion. Anti-inflammatory signals are more prominent, guiding the resolution of responses that began during the day. This is one reason why rest is so important in recovery. It allows the inflammatory process to complete its cycle without unnecessary interference. In the stillness of the night, inflammation may be quietly repairing the skin after a small scrape, soothing the tissues around a strained muscle, or rebuilding microscopic structures within organs. You may not be aware of this activity, yet it is part of the ongoing maintenance that keeps the body whole. The elegance of inflammation lies in its balance. Too little, and the body cannot defend or repair itself effectively. Too much, and the protective process can begin to cause harm. The healthy body achieves a middle path, activating inflammation when needed, guiding it with precision, and closing it down when the work is done. In this way, inflammation is not a state of disturbance, but a sign of the body's attentiveness, a reminder that even in the smallest of challenges, there is a system ready to respond, to protect, and to restore. It is one of the many quiet assurances that the body is never passive, but always engaged in the gentle work of preserving life. And so, as you rest, the measured rhythm of inflammation plays out where it is needed, unseen yet purposeful. Its presence is not meant to alarm, but to reassure, for it means the body is aware, active, and committed to your healing. When morning comes, its work will continue as needed, or quietly fade if the balance has been restored, leaving behind tissues renewed and ready for the day ahead. 13. Immune memory. Learning for the future. Among the immune system's most remarkable qualities is its ability to remember. Like a wise teacher who never forgets a lesson learned, the immune system stores the details of past encounters, creating a memory that can last for years, decades, or even a lifetime. This memory transforms the body's defenses from a reactive shield into a prepared guardian, ready to respond with speed and precision should the same challenge appear again. The process begins with the adaptive immune system, the branch of immunity that specializes in specificity. When a new pathogen, such as a virus or bacterium, enters the body, it carries with it a unique molecular fingerprint, known as an antigen. These antigens are recognized by highly specialized immune cells, B lymphocytes and T lymphocytes. Each of these cells is tuned to detect a specific antigen, much like a lock designed for a single key. When an antigen is detected for the first time, the response is deliberate and careful. The immune system studies it, creating antibodies, proteins precisely shaped to bind to that antigen and mark it for destruction. T cells join the effort, some helping to coordinate the broader immune response, others directly attacking infected cells. This first encounter can take several days to bring under control, as the immune system must build its specialized army from a small pool of cells already tuned to that antigen. But during this first battle, something else happens. A record is kept. Some of the B cells and T cells activated in the response transform into memory cells. These cells do not join the immediate fight for long. Instead, they step aside, storing the detailed recognition patterns of the invader. They circulate quietly through the bloodstream or rest in the lymph nodes, waiting. If the same antigen appears again, the difference is profound. Instead of searching for the right cells and slowly multiplying them, the immune system calls on its memory cells. These cells recognize the intruder instantly, prompting a faster and more powerful response. Antibodies can be produced in greater quantities within hours rather than days, and targeted T cells can arrive before the pathogen has a chance to spread widely. This capacity for memory underlies the principle of vaccination. By exposing the immune system to a harmless form of an antigen, perhaps a weakened or inactive version of a pathogen, or even just a small fragment of it, the body can learn to recognize it without the risk of illness. The memory formed in this way is just as strong as that from a natural infection, allowing the immune system to respond rapidly if the true pathogen is ever encountered. Immune memory is not uniform. Some memories fade over time, while others remain for life. The duration depends on many factors: the nature of the antigen, the strength of the initial immune response, and the continuing presence or absence of similar antigens in the environment. For example, certain viral infections can leave behind memory that lasts decades, while other responses require occasional reminders, as in the case of booster vaccinations. The memory held by the immune system is also adaptive in a deeper sense. Memory cells are not static records. They can refine themselves, producing antibodies that are better suited to neutralizing a pathogen than those made during the first encounter. This process, known as affinity maturation, means that the immune system's memory grows more effective with each exposure. While immune memory is often discussed in terms of protection against illness, it also plays a role in maintaining balance with the countless harmless organisms the body encounters daily. By remembering which antigens are not a threat, the immune system avoids unnecessary responses, preserving energy and preventing disruptions to the body's own tissues. The memory of the immune system is stored not in a single location, but throughout the body. Memory B cells may linger in the bone marrow, ready to release antibodies into the bloodstream at the first sign of a familiar antigen. Memory T cells may patrol specific tissues, standing guard in the skin, the lungs, or the digestive tract, where they are most likely to encounter returning invaders. Some remain in the lymph nodes, where they can coordinate a rapid response across multiple areas at once. This distributed nature of immune memory ensures that the body is never caught off guard. Whether the challenge appears at the surface of the skin, deep within the lungs, or in the bloodstream itself, there is a record keeper nearby, prepared to raise the alarm and summon reinforcements. During sleep, immune memory strengthens. Studies have shown that the consolidation of immune memory, much like the consolidation of mental memory, is enhanced during rest. This may be partly due to the hormonal changes that occur at night, such as increased levels of growth hormone and melatonin, which support immune cell activity. In the calm of the night, memory cells may proliferate, antibodies may be fine-tuned, and the patterns of recognition may be reinforced, preparing the immune system for the future. Immune memory is, in many ways, a quiet form of hope within the body, a belief, built into biology, that what has been learned will not be forgotten, and that challenges once faced will be met more easily if they return. It is a record not just of danger, but of resilience, each memory cell carrying the story of a battle fought and won. And so, as you rest, the keepers of these stories are moving gently through your body. Some float in the blood, others rest in the lymph nodes, still others linger in the tissues, all holding their quiet knowledge. They do not speak, yet they are prepared to act. They are the living archives of your immune system, ensuring that each new day begins with the protection earned from all the days before. 14. Immune and endocrine communication, a dialogue of systems. Within the human body, no system works in isolation. The immune and endocrine systems, though distinct in their primary roles, are deeply connected in a continuous exchange of information. This dialogue ensures that the body can respond to changes both within and beyond, adjusting its defenses, metabolism, and internal balance with quiet precision. The immune system's task is to guard and repair. The endocrine system's task is to coordinate and regulate. Together, they form a partnership that blends vigilance with harmony. This communication begins at the most fundamental level through chemical messengers. The immune system speaks in the language of cytokines, small proteins released by immune cells to signal distress, coordinate attacks, or call for resolution. The endocrine system, in turn, uses hormones, secreted by glands into the bloodstream, to influence growth, metabolism, mood, and countless other processes. These two languages are not separate dialects. They can be understood by both systems. Cytokines can influence hormone production, and hormones can shape immune responses. One of the most familiar examples of this dialogue can be found in the stress response. When the body perceives a threat, physical, emotional, or environmental, the hypothalamus in the brain signals the adrenal glands to release cortisol, a hormone that prepares the body for action. Cortisol increases blood sugar for energy, sharpens mental focus, and alters immune activity. In the short term, this is protective, as it prevents the immune system from overreacting during a moment of urgency. Once the stress passes, cortisol levels fall, and immune activity returns to normal, allowing repair and recovery to proceed. This pattern reflects a broader truth. The immune and endocrine systems are constantly negotiating. Hormones such as cortisol, estrogen, progesterone, testosterone, and thyroid hormones all influence the pace and strength of immune responses. Some, like cortisol, tend to suppress certain immune activities, preventing excessive inflammation. Others, like estrogen, can enhance specific immune functions, sometimes giving the female immune system a greater responsiveness in certain contexts. In the other direction, immune signals can influence endocrine glands. During an infection, cytokines may prompt the brain to adjust hormone levels, slowing metabolism to conserve energy, or altering reproductive hormones to focus resources on healing. In this way, the immune system can temporarily reshape priorities across the body, ensuring that the most urgent needs are met first. The thymus, an organ often associated only with immunity, is a living example of this integration. Situated in the upper chest, it is where T lymphocytes mature, learning to recognize and respond appropriately to antigens. Yet the thymus is also sensitive to hormonal cues. Its activity changes with age, partly under the influence of endocrine signals, and in turn, it produces hormones of its own that affect immune cell development. The thyroid gland, which regulates metabolism, also interacts with the immune system. Its hormones influence how quickly immune cells can act, how rapidly they proliferate, and even how effectively they communicate. In times of illness, the immune system may signal the thyroid to subtly adjust its output, conserving energy for healing rather than growth. This exchange is not only about responding to challenges, it also helps maintain daily balance. During sleep, for example, melatonin from the pineal gland influences immune cell activity, encouraging repair and the strengthening of immune memory. Growth hormone, released in pulses during deep sleep, supports tissue regeneration, including that guided by the immune system. In turn, the immune system uses nighttime hours to send quiet signals to endocrine organs, reinforcing the cycles that will shape the coming day. Reproductive hormones are part of this dialogue as well. Estrogen and progesterone can influence the immune system's sensitivity, sometimes shifting its balance between active defense and quiet tolerance. This is especially important during pregnancy, when the immune system must protect both the mother and the developing child without treating the child as an invader. The endocrine system adjusts hormone levels to guide this delicate balance, while the immune system modifies its behavior in response. Even subtle changes in the environment, a shift in season, a change in daylight hours, a difference in diet, are communicated across these systems. The endocrine system senses these changes and adjusts hormone levels. The immune system interprets the signals and alters its readiness accordingly. This adaptability is part of what has allowed human beings to thrive in so many different climates and conditions. When this dialogue is balanced, the body moves through its cycles with ease. The immune system stands ready without being overly active, and the endocrine system coordinates responses without unnecessary strain. This balance supports resilience, the ability to adapt to challenges, recover from illness, and maintain health over time. During rest, the conversation between these systems becomes especially gentle. Hormones shift toward a state that favors healing. Melatonin rises, cortisol falls, growth hormone pulses quietly. The immune system, receiving these cues, focuses on repair, memory formation, and the quiet removal of damaged cells. Cytokines, in turn, signal back to the endocrine organs, confirming that the night's work is proceeding smoothly. This exchange is so seamless that it passes unnoticed. There are no conscious sensations of cytokines being released or hormones adjusting their levels. Yet in this quiet dialogue, the body maintains a state of readiness and repair that is essential for long-term well-being. The immune and endocrine systems are, in essence, two storytellers sharing the same narrative. One speaks of defense, the other of coordination, and together they ensure that the story moves forward in harmony. Each listens to the other's cues. Each adapts its role to support the whole. It is a partnership without hierarchy, where strength comes not from dominance, but from balance. And so, as you lie in the calm of night, this conversation continues, unbroken, unhurried. Hormones circulate with quiet purpose. Immune cells adjust their activity in response, and the two systems together weave the conditions for health. By morning, their work will have prepared you for the day ahead, alert yet calm, ready yet at ease, the product of a dialogue that has been running since the first moments of life. 15. When communication falters, is love 10 has 2, 10 has 2, and for 17:1, 10 has 2. In the healthy body, the immune and endocrine systems engage in a constant, measured dialogue, adjusting to one another's signals in a way that sustains harmony. This balance allows the body to respond to challenges without overreacting, to repair itself without wasting resources, and to adapt to changes without losing stability. But like any finely tuned partnership, communication can sometimes falter. When the exchange between these systems is disrupted, the result can be an imbalance that ripples through the entire body. Disruption can begin in many ways. A prolonged period of stress, for example, can keep cortisol levels elevated for too long. Cortisol's natural role is to regulate inflammation and immune activity, but when it remains high beyond the body's needs, it can begin to suppress immune defenses excessively. The immune system, in turn, becomes less able to respond to infections or repair tissues efficiently. The constant presence of high cortisol also affects other hormones, such as those regulating metabolism and reproductive function, gradually altering the body's priorities in ways that may be protective in the short term, but harmful over time. At the other extreme, if cortisol is chronically low, as can occur in certain endocrine disorders, the immune system may become overly active, releasing inflammatory signals without proper restraint. This can lead to persistent low-grade inflammation that quietly strains tissues and organs. Over months or years, this silent activity may contribute to fatigue, joint discomfort, or a general sense of malaise that resists simple explanation. Some imbalances arise when the immune system mistakes the body's own tissues for harmful invaders. This phenomenon, known as autoimmunity, is often influenced by endocrine signals. Certain hormones can increase immune vigilance, which is beneficial in fighting infections, but may, in susceptible individuals, also heighten the risk of immune cells misidentifying self as other. The thyroid gland is a common site of such interactions. Autoimmune thyroid conditions can alter metabolism, mood, and energy levels, and these changes can, in turn, influence immune behavior. Hormonal changes across life stages can also shift the balance. During adolescence, for example, fluctuations in sex hormones can temporarily influence immune activity, sometimes leading to changes in skin health or inflammation levels. In pregnancy, the endocrine system adjusts to protect the developing child, often suppressing certain immune responses to prevent rejection of the fetus. While this is a finely tuned adaptation, it can make the body more susceptible to certain infections during this time. Later in life, during menopause or andropause, declining sex hormone levels can subtly alter immune responsiveness. shifting the balance between activity and tolerance. Environmental factors can compound these internal shifts. Poor sleep, limited sunlight exposure, nutritional imbalances, and exposure to pollutants can all affect both hormone production and immune function. For example, inadequate sleep can reduce melatonin levels, which not only influences the body's circadian rhythm, but also affects immune regulation. Similarly, insufficient vitamin D, a nutrient that acts like a hormone in the body, can weaken immune readiness and disrupt communication with the endocrine system. Chronic inflammation is another way this balance can falter. When inflammation persists beyond its useful purpose, it sends ongoing distress signals that can disrupt hormonal patterns. The endocrine system, sensing the body in a constant state of alert, may shift resources away from growth, reproduction, and long-term repair toward immediate energy use. This can lead to slower healing, altered metabolic function, and reduced resilience to stress. The effects of disrupted communication can be subtle at first, perhaps a tendency to catch colds more easily, slower recovery from minor injuries, or changes in energy levels. Over time, however, the consequences can become more noticeable. The body may struggle to maintain stable temperature, weight, or mood, or it may develop patterns of inflammation that affect joints, skin, or digestion. Restoration of balance often begins with quiet, consistent adjustments rather than dramatic interventions. Adequate rest, gentle physical activity, nourishing food, and a supportive environment can all help reestablish the dialogue between the immune and endocrine systems. In many cases, the body is capable of resetting its rhythms if given the time and resources to do so. Stress management through relaxation, meditation, or simply creating space for stillness can lower excessive cortisol and allow immune activity to return to a more balanced state. The process is gradual, and the body prefers it that way. Just as balance is lost over time, it is often regained through steady, small steps. Each night of restful sleep, each meal rich in essential nutrients, each moment of deep breathing contributes to the quiet repair of the connection between these two systems. Over time, the immune system becomes more measured in its responses, and the endocrine system more responsive to true needs rather than constant demands. Even in moments of imbalance, the underlying connection between the immune and endocrine systems remains. The lines of communication are never truly broken, only clouded by the signals of strain. Given the right conditions, these pathways can clear, restoring the subtle rhythms that allow the body to thrive. As you rest tonight, your body is already working toward balance. Hormones are shifting toward patterns that favor healing, and immune cells are adjusting their activity in response. The same channels that may have carried signals of strain can carry signals of restoration. With time, the partnership between these systems can regain its steadiness, and the harmony that underlies all health can return. 16. Protective lifestyle rhythms. The immune and endocrine systems thrive on patterns. While they are capable of adapting to sudden changes when necessary, they perform best when the body moves through a steady cycle of nourishment, activity, rest, and recovery. These rhythms are not rigid rules but gentle currents that guide the body's functions, ensuring that energy is used wisely, signals are clear, and the dialogue between systems remains harmonious. Establishing these rhythms is less about discipline and more about creating an environment in which the body's natural timing can reassert itself. One of the most important rhythms for both systems is the daily cycle of wakefulness and rest, the circadian rhythm. Governed by a small cluster of neurons in the hypothalamus, this internal clock responds to cues like light and darkness, meal timing, and activity levels. It influences the release of hormones such as cortisol, melatonin, and growth hormone, each of which plays a role in immune regulation. Cortisol, for example, normally peaks in the morning to prepare the body for the day and tapers off by evening, allowing melatonin to rise and encourage restorative sleep. When this rhythm is stable, the immune system receives clear signals about when to focus on active defense and when to shift toward repair. Sleep itself is a cornerstone of protective rhythms. During deep sleep, the endocrine system releases pulses of growth hormone, which supports tissue repair and regeneration, while the immune system uses the reduced demands of wakefulness to clear damaged cells, strengthen immune memory, and coordinate responses to any lingering threats. Regular, unbroken sleep allows these processes to unfold fully. Even small disruptions, a later bedtime, inconsistent wake times can shift hormone release patterns, leading to subtle changes in immune activity. Nutrition also shapes the daily dialogue between the immune and endocrine systems. Meals provide the raw materials for hormones, immune cells, and the proteins they produce. A balanced intake of proteins, healthy fats, complex carbohydrates, vitamins, and minerals ensures that both systems have what they need to function smoothly. Certain nutrients, like vitamin D, zinc, selenium, and omega-3 fatty acids, have direct effects on immune cell performance and hormone synthesis. Eating at consistent times helps the endocrine system maintain predictable insulin rhythms, which in turn stabilizes energy availability for immune functions. Physical activity, when done with balance, acts as another powerful synchronizer. Moderate, regular exercise stimulates circulation, which helps hormones and immune cells move efficiently through the body. It also supports lymphatic flow, enhancing the removal of cellular waste. Exercise temporarily raises stress hormones like cortisol, but when practiced consistently, it trains the endocrine system to respond more effectively, and it often reduces baseline cortisol over time. Excessive or irregular exercise, however, can strain these systems, highlighting the importance of moderation and recovery. Exposure to natural light anchors the circadian rhythm. Morning sunlight, in particular, signals the brain to regulate melatonin and cortisol in proper sequence. This not only improves sleep quality, but also supports seasonal adjustments in hormone levels and immune readiness. Time spent outdoors also brings indirect benefits. Fresh air, movement, and moments of mental rest that help keep stress hormones in check. Equally important are the rhythms of mental and emotional balance. Psychological stress has a powerful influence on endocrine function, often through sustained cortisol release, which in turn affects immune performance. Gentle practices that promote calm, whether breathing exercises, meditation, slow walks, or creative activities help restore a state in which both systems can function without the constant background noise of stress signals. Seasonal changes offer another natural rhythm. The endocrine system subtly shifts hormone production in response to variations in daylight, temperature, and environmental activity. The immune system also adapts, altering its readiness to match seasonal patterns of pathogens and physical demands. Working with these shifts, adjusting sleep schedules to changing daylight, eating seasonal foods, varying activity levels allows the body to align more closely with its environment, reducing strain on the systems that regulate adaptation. Hydration, though often overlooked, supports both systems. Adequate fluid intake ensures that hormones and immune cells move easily through the bloodstream and lymphatic vessels. It also helps maintain the mucous membranes that serve as the body's first line of defense, keeping them moist and effective. Regular, steady hydration is more beneficial than large, infrequent intakes, as it provides consistent support to the body's processes. The beauty of protective lifestyle rhythms is that they reinforce one another. A well-timed meal supports sleep. Good sleep enhances hormonal balance. Balanced hormones improve the immune response. A stable immune system reduces the stress load on the endocrine system. Over time, these small cycles form a larger, self-sustaining pattern of health. At night, these rhythms settle into their most restorative phase. Hormones shift toward repair and renewal. Immune cells patrol quietly, and the brain organizes both mental and immune memories. The body is not idle, it is simply working in a mode that requires your stillness. By morning, the coordinated efforts of these systems, guided by the rhythms you've set, leave you better prepared to meet the day's demands with both resilience and ease. Protective rhythms do not need perfection to be effective, they only need consistency. Even modest improvements in sleep timing, meal patterns, or daily exposure to light can produce measurable benefits over time. The body is patient, and it responds to gentle changes with lasting adjustments. In this way, the immune and endocrine systems can maintain their quiet dialogue without interference, each one strengthening the other. The harmony that results is not fragile but adaptable, capable of weathering the inevitable shifts of life while preserving the inner balance that supports health. 17. The night's hidden work. When the day's noise subsides and the body drifts into sleep, a different kind of activity begins, quieter, slower, yet deeply purposeful. Rest is not an idle state. It is a carefully orchestrated phase of renewal in which the immune and endocrine systems, along with every organ, shift into modes of repair and rebalancing. This hidden work is essential for sustaining health, and its benefits accumulate night after night, weaving resilience into the fabric of the body. Sleep unfolds in cycles, each with distinct patterns of brain activity, hormone release, and immune engagement. Early in the night, as the body moves into deep, slow-wave sleep, the pituitary gland releases pulses of growth hormone. This hormone is not only for childhood development in adults, it fuels cellular repair, stimulates tissue regeneration, and supports the immune system's maintenance of healthy cells. During these hours, muscles damaged by daily activity begin mending, small tears in tissues are sealed, and microscopic debris is cleared away. At the same time, the immune system takes advantage of the stillness. Certain white blood cells, such as natural killer cells and T lymphocytes, become more active at night, moving into tissues to scan for any lingering threats. This nocturnal vigilance is aided by the slower pace of other bodily functions, which frees resources for immune surveillance and repair. Cytokines, the immune system's messengers, are produced in higher amounts during sleep, guiding both defense and restoration. Some cytokines promote healing, while others strengthen immune memory, ensuring that lessons learned from recent exposures to pathogens are stored for future use. The night is also when the lymphatic system, a specialized waste clearance pathway in the brain, becomes more active. By circulating cerebrospinal fluid through brain tissue, it flushes away metabolic byproducts that accumulate during waking hours. This cleansing is thought to help maintain mental clarity, mood balance, and even long-term brain health. Though it is not a direct function of the immune or endocrine systems, it supports them by keeping neural communication clear and reducing the inflammatory signals that can arise from accumulated waste. The endocrine system coordinates much of the timing of this nocturnal work. Melatonin, released by the pineal gland as darkness falls, not only promotes sleep, but also has antioxidant properties that help protect cells from oxidative stress. Its presence signals other hormones to adjust cortisol drops to its lowest levels of the day, easing the immune system into a more active repair mode. Later in the night, as morning approaches, cortisol begins to rise gently, preparing the body for wakefulness without abruptly ending the night's restoration. Deep sleep is followed by lighter stages and rapid eye movement, REM, sleep, during which the brain's activity becomes more vivid and dynamic. While REM is often associated with dreaming, it is also a time when certain hormonal and immune adjustments continue. The balance between slow wave and REM stages ensures that both physical and mental renewal are addressed, one repairing the body's structures, the other organizing and integrating memories, including immune memories from recent encounters. Hydration, temperature, and breathing all subtly influence how effectively the night's work unfolds. The body's core temperature naturally drops during sleep, creating conditions that favor deep rest and optimal hormone release. Breathing becomes slower and more rhythmic, supporting oxygen delivery to tissues while allowing the cardiovascular system to relax. Even the lymphatic system benefits from this gentle pace, as the reduced competition for energy resources makes it easier to carry away waste fluid from tissues. This nightly renewal is not only about repair, it is also about calibration. The immune system uses sleep to reassess its readiness, reducing unnecessary activity in areas where threats have passed, and reinforcing protection where it may be needed. The endocrine system, in turn, adjusts hormone levels to match the anticipated demands of the coming day, drawing on information gathered from the previous day's activity and stress patterns. Over time, the cumulative effect of consistent, restorative sleep, the body heals more efficiently from injuries, resists infections more effectively, maintains steadier energy, and manages stress with greater ease. Conversely, when the night's hidden work is disrupted by insufficient sleep, irregular sleep patterns, or environmental disturbances, the consequences can be felt quickly. Hormone rhythms become less precise, immune responses less coordinated, and repair processes less thorough. The beauty of this nightly renewal is that it requires no conscious effort beyond allowing it to happen. The same systems that defend and regulate you by day transform their roles at night, prioritizing what will serve you best in the hours ahead. They are steady, patient workers, unbothered by the passage of time, moving always toward balance and readiness. As you rest, these processes are unfolding quietly. Hormones are pulsing in measured waves, immune cells are patrolling and repairing, and the brain is sweeping itself clear of the day's remnants. It is a choreography older than memory, repeated every night in countless lives, sustaining the intricate web of connections that keep the body whole. By the time morning light touches the skin, the hidden work of the night has already prepared you not only for another day, but for the many days to come. 18. Adaptation and flexibility. Responding to change. The human body is not a static machine. It is a living system, designed not just to maintain balance, but to adjust that balance when the environment, the seasons, or the body's own internal conditions shift. This capacity for adaptation is one of the most remarkable qualities of life, a quiet, continuous process that allows us to thrive in conditions that are rarely perfect or predictable. For the immune and endocrine systems, adaptability is a necessity. Together, they act as both sentinels and architects, responding to change in ways that preserve health while conserving the body's resources. Adaptation begins with awareness. The immune system reads the world through its constant surveillance, detecting even the smallest signs of injury, infection, or internal stress. The endocrine system senses change in another way by monitoring chemical and physical signals such as nutrient levels, temperature shifts, and patterns of light and darkness. Each system then translates what it has perceived into messages the other can understand, ensuring that both are informed before any adjustments are made. This collaboration is perhaps most visible during seasonal transitions. As daylight hours shorten in autumn, the pineal gland responds by adjusting melatonin production, subtly altering the body's circadian rhythm. This change ripples through the endocrine system, influencing cortisol timing, thyroid activity, and even reproductive hormone patterns. The immune system, in turn, adjusts its readiness, preparing for the increased exposure to seasonal pathogens that often comes with cooler weather and more time spent indoors. Temperature extremes also call for this flexibility. In cold environments, the endocrine system signals for increased metabolic activity, encouraging the thyroid to produce more hormones that generate heat. The immune system supports this by fine-tuning inflammation and circulation to protect extremities without compromising the body's core temperature. In heat, the reverse occurs. Hormone levels shift to slow metabolism slightly. Immune activity adjusts to prevent unnecessary heat-producing inflammation, and the skin's blood vessels open wider to release excess warmth. Dietary changes are another form of environmental input that prompts adaptation. If nutrient intake decreases, the endocrine system may slow metabolism and conserve energy, while the immune system prioritizes essential defense functions over less urgent tasks, like certain types of tissue renewal. When food becomes more abundant or varied, both systems can expand their activities again, restoring full capacity for repair, reproduction, and growth. Adaptation is also critical during life events that challenge the body's usual balance. Physical exertion, for example, requires an immediate endocrine response. Adrenaline and cortisol rise to mobilize energy, while insulin adjusts to help direct glucose where it is needed most. The immune system temporarily shifts resources toward repair of muscle fibers and protection against opportunistic infections that can take advantage of post-exercise fatigue. With regular training, both systems become more efficient at making these adjustments, a process known as physiological conditioning. Emotional and psychological stressors engage these adaptive pathways as well. Short-term stress can sharpen immune readiness and mobilize endocrine responses that provide quick energy, but long-term stress requires a more careful balance. Too much sustained cortisol can dampen immunity, while too little may leave the body prone to overactive inflammatory responses. The adaptability of these systems includes the ability to recalibrate after the stressor passes, gradually restoring pre-stress patterns so that the body is not locked in a constant state of alert. Illness and injury provide another test of flexibility. When an infection strikes, the immune system raises its defenses, often inducing fever, altering blood flow, and shifting energy use toward fighting the invader. The endocrine system supports this by adjusting hormones that influence metabolism, appetite, and even sleep, encouraging behaviors that promote recovery. Once the illness resolves, both systems must actively turn off their heightened responses, reestablishing a state that supports long-term maintenance rather than short-term defense. This ability to adapt is not without limits, and the body prefers gradual change to sudden extremes. Rapid or repeated swings in environmental conditions, stress levels, or nutrition can strain both systems, making it harder for them to maintain clear communication. That is why steady, supportive habits, regular sleep, balanced meals, and periods of true rest give the immune and endocrine systems a stable foundation from which to adapt more effectively. Nighttime plays a particularly important role in adaptation. While the body sleeps, these systems review and integrate the day's signals, making subtle adjustments that prepare for the next day's conditions. If a recent exposure to a virus was detected, the immune system may allocate more resources to defense overnight. If recent meals have been rich in nutrients, the endocrine system may increase hormone output that supports tissue growth and repair. This constant fine-tuning is invisible to us, but it is the essence of resilience. The adaptability of the immune and endocrine systems is not about resisting change, but embracing it with precision. It is the difference between being swept away by shifting currents and adjusting the sails to move forward steadily, regardless of the wind. These systems do not seek to freeze the body in one perfect state. They seek instead to keep it moving within a range of health that can shift and sway as needed. As you rest, adaptation is happening now. Hormones are rising or falling to match your recent experiences. Immune cells are adjusting their activity based on subtle cues from your environment and your own body. And the partnership between these systems is quietly ensuring that you will be prepared for tomorrow's demands, whatever they may be. The night is not just a time for repair, it is also a time for preparation, when the body sets its course for the next phase of its journey, ready to bend without breaking, to shift without losing its center. 19. The miracle of integration. All systems as one. When we think of the body, it is tempting to picture its systems separately. The immune system as a vigilant guard, the endocrine system as a master of chemical signals, the cardiovascular system as a network of flowing life, and so on. Yet in reality, These divisions exist only in diagrams and textbooks. Within you, there is no true boundary where one system ends and another begins. The human body is an unbroken whole, a living fabric woven from countless threads of communication, cooperation, and shared purpose. Integration is the reason life is possible. The immune system could not protect you without the blood vessels that carry its cells, the hormones that influence its timing, or the skin and mucous membranes that form its barriers. The endocrine system could not regulate your internal world without feedback from the nervous system, the nutrients delivered by digestion, or the signals from the immune system that reveal the state of your health. Every process in the body is linked to every other directly or indirectly in a network so intricate that even the smallest action sends ripples across the whole. Consider something as simple as a small cut on the skin. The moment the injury occurs, nerves sense the break and signal the brain. The immune system sends cells to prevent infection and begin repair. The endocrine system releases hormones that manage inflammation and direct energy toward healing. The cardiovascular system delivers the necessary cells and materials. The skin's own cells, guided by chemical cues, begin closing the gap. None of these steps occur in isolation. They are all part of a single, integrated response to restore balance. This unity is not just functional, it is also rhythmic. The body moves through daily cycles in which all systems subtly adjust together. In the morning, light signals through the eyes trigger the brain to reduce melatonin and increase cortisol, waking the mind and body. The cardiovascular system quickens its pace, delivering oxygen and nutrients more rapidly. The digestive system prepares to receive food, and the immune system adjusts its activity to match the day's anticipated exposures. At night, these patterns reverse, with hormone levels, immune activity, and metabolic processes all shifting toward rest and renewal. Even when a single system appears to be taking the lead, in a moment the heart during exercise, the digestive system after a meal, the immune system during illness, the others are never passive. They adjust, support, and influence one another, ensuring that the whole remains stable even as demands change. This is the miracle of integration, that each part is fully itself, yet inseparable from the rest. The nervous system plays a central role in maintaining this unity, acting like a vast communication network that carries signals between distant parts of the body. But the communication is not one-way. Hormones influence nerve activity. Immune cells can signal to neurons, and metabolic changes can affect both thought and sensation. The body does not operate like a chain of command, but like a circle, with messages flowing freely in all directions. This integration also allows for remarkable adaptability. Because the systems are interlinked, a temporary weakness in one area can be compensated for by adjustments elsewhere. If the immune system is under strain, the endocrine system can alter hormone output to conserve resources or shift metabolic priorities. If energy stores are low, the cardiovascular and muscular systems can adjust activity to reduce demands. This is why the body is able to recover from challenges that might otherwise be overwhelming. Each part works not just for itself, but for the whole. Integration extends beyond the body's physical boundaries. The environment you live in, the food you eat, the air you breathe, the light you see, the people you interact with, shapes the signals that move through your systems. A warm meal, a peaceful walk, or a quiet conversation can ripple through the endocrine system as hormone levels shift, through the immune system as stress signals soften, and through the cardiovascular system as heart rate and blood pressure ease. In this way, the integration of your systems is also an integration with the world around you. At night, this unity becomes especially apparent. As you sleep, there is no conscious awareness of your systems at work, yet they move together in quiet synchronization. Hormones rise and fall in patterns that match immune activity, heart rate, and brain waves. Repair and memory processes in the brain occur alongside tissue renewal in the muscles and fine-tuning of metabolic pathways in the liver. Even in stillness, the body is alive with connection, each system knowing its place in the larger whole. The miracle of integration is that it is effortless from your perspective. You do not need to think about how to balance hormone levels, how to direct immune cells, or how to coordinate breathing with circulation. The body's systems, evolved over millions of years, perform this integration automatically, constantly adjusting to maintain a state of health that is as dynamic as it is stable. To appreciate this integration is to understand that health is not the absence of change, but the ability to move through change without losing harmony. Each system's role is important, but it is their cooperation, their constant conversation, that creates the resilience to face each day's demands. You are not a collection of separate parts, but a single, whole being in which countless processes work together with one purpose: to sustain life. And so, as you rest, remember that your body is not simply repairing itself piece by piece. It is sustaining the entire network of relationships that make you who you are. Every breath, every heartbeat, every signal from one cell to another is part of this quiet integration. In the silence of night, the miracle continues steady, patient, and complete. 20. Gratitude for our body's harmony. As the day draws to a close and the steady hum of life outside softens into evening quiet, your body continues its own quiet symphony. The heart beats in its measured rhythm, lungs fill and empty without thought, and the subtle orchestration of hormones, immune cells, and countless other processes carries on without hesitation. In the stillness of night, this hidden work becomes even more precious. Here, in these moments, it is possible to feel a deep and lasting gratitude for the harmony that sustains life within you. Gratitude begins with noticing, truly noticing the quiet constancy of your body. Beneath the surface, an extraordinary collaboration is taking place. The lungs draw in air with each breath. The cardiovascular system sends oxygen to every cell, and the immune system quietly guards each boundary. Hormones drift through the bloodstream, carrying messages from one organ to another, adjusting the body's state to match both inner and outer conditions. The skin shields and senses, acting as the first line of defense while also providing the sense of touch that connects you to the world. Even in perfect stillness, the body is a landscape of movement, balance, and exchange. This harmony is not a fragile balance, but a living, responsive relationship between systems. When one area requires more attention, others adjust their roles to support it. If the immune system must increase its activity to fight a virus, the endocrine system alters hormone levels to conserve energy and direct resources toward healing. The cardiovascular system may shift blood flow, delivering oxygen and nutrients where they are most needed. Recovery from any challenge is never the work of one system alone. It is a group effort, a coordinated response where every part contributes to restoring equilibrium. The patience of the body is something worth acknowledging. Every beat of the heart, every chemical signal, every quiet repair in the night is part of a process that has been ongoing since before your first conscious thought. These processes require no deliberate control on your part. They carry on in the background, adapting to your needs, whether or not you are aware of them. You may not feel the immune system's microscopic inspections, or the way hormones shift gently in response to your environment, but these actions form the foundation of your health. Gratitude deepens when we remember that the body does not exist in isolation. Its harmony is shaped by the larger cycles of nature. The rising and setting of the sun influence your circadian rhythm, guiding the ebb and flow of hormones such as cortisol and melatonin. Seasonal changes gently shift immune readiness, metabolism, and even mood. The food you eat, drawn from the earth, becomes the building blocks for new cells and the fuel for every movement. The air you breathe, rich with oxygen from plants, sustains every heartbeat and thought. You are not separate from your environment, your body is in constant conversation with it. At night, this conversation becomes softer, more inwardly focused. The immune system increases its efforts in tissue repair, scanning for damaged or worn cells and replacing them. The endocrine system shifts into patterns of renewal, releasing hormones that encourage deep rest and cellular restoration. The nervous system slows, giving space for the mind to process the day's experiences, while also allowing the body to prioritize physical healing. Heart rate and breathing become more rhythmic, and the body's core temperature lowers slightly to create ideal conditions for restorative sleep. These nightly patterns are a reminder that rest is not an interruption of life's work, but a vital part of it. The harmony you carry within depends on these periods of renewal, where the body can strengthen its systems and prepare for the next day's demands. Each night of deep rest is a gift to every cell, every tissue, every system, and it is worth pausing to appreciate this gift even as it is happening. Gratitude for the body's harmony can be felt in the simplest of ways, in the comfort of a slow, steady breath, in the ease of movement after rest, in the quiet clarity that comes after a good night's sleep. It is not about striving for perfection, but about recognizing that the body is always working toward balance, even in challenging circumstances. Trusting in this process can bring a sense of peace, a release from the need to control every detail. Trust mirrors the way the body itself functions. The immune system trusts that the endocrine system will provide the right hormonal cues at the right time. The cardiovascular system trusts that the lungs will deliver oxygen with each breath. The digestive system trusts that nutrients will be distributed where they are needed. This trust is built into every interaction, every exchange of signals, every shared task. It is a kind of wisdom written into the very structure of life. And so, as this exploration of the body's interconnected systems comes to a close, it is fitting to return to the simple truth that has been woven throughout. You are whole. The lines we draw between systems are for understanding, but in reality, there are no separations, only continuous, flowing connections. You are not a collection of independent parts, but a living network of relationships, each one sustaining and being sustained by the others. In moments of health, this harmony moves quietly in the background, barely noticed. In moments of challenge, its presence becomes clear, as the body rallies every resource to restore balance. In both cases, the integration of systems is what makes life possible. To reflect on this is to recognize the miracle not only of human biology, but of being alive in this very moment. Tonight, as you settle into rest, you can let this awareness become a gentle backdrop to your thoughts. You do not need to hold it tightly. The body will continue its work whether you think of it or not. Your heart will keep beating, your lungs will keep drawing in air, your immune system will keep watch, and your endocrine system will continue adjusting the body's rhythms. The harmony will carry on, steady and patient, through the night and into the day ahead. There is nothing more you need to do now. The systems are aligned, the rhythms are in place, and the miracle of integration is unfolding quietly within you. Simply resting in gratitude for this harmony is enough. And when you awaken, you will carry it with you, supported by the same intricate cooperation that has been with you from your first breath and will remain until your last.